The broadcast is now starting. All attendees are in listen-only mode.
Goedemorgen, welkom allemaal. We zullen nog een aantal minuutjes, 2 minuutjes even wachten, zodat iedereen langzaam binnen kan druppelen in het webinar. En dan zullen we zo gaan starten. Goedemorgen allemaal. Welkom bij het SentinelOne Cloud Workload Protection Platform webinar. Mijn naam is Hilde van Kessel, verantwoordelijk voor onder andere SentinelOne Marketing bij Exclusive Networks. Onze presentator is Tapio Varamaki, onze Technical Evangelist uit Finland. En hij zal het webinar gaan presenteren en ook een korte demo laten zien van het platform. Aan de achterkant is Lars Boerenkamp ook aanwezig, accountmanager SentinelOne. Dus mochten er vragen zijn, kunt u deze stellen in de chat en kunnen wij deze gedurende het webinar tackelen of beantwoorden. En anders beantwoordt Tapio deze aan het einde van het webinar. Tapio, the stage is yours. Good luck.
Okay, very good and good morning to everyone and welcome to our session today. Our contents, our webinar today will be discussing about the cloud workload protection platforms, and we are doing this together with SentinelOne, which is one of the leading EDR vendors in the market. And the structure of today's session will be so that we first start with a bit more theoretical part, like, okay, what is this whole CWPP thing? It's a term that this Gartner has defined. So we are going through the basics of that, and then we are diving in a little bit into more details into how SentinelOne is actually doing this, how SentinelOne can help you to protect your cloud workloads. And then if time allows, we can even have a little demo in the end. And I think we are ready to start. And Hilde, I'm not sure if we have a possibility to run any polls over here, but maybe as a good backgrounding item, we could ask from the people that if they can define from 1 to 5 that how familiar they are with the containers, how comfortable they feel with containers. We could, ask people that from scale 1 to 5. 1 is that I'm not feeling comfortable with containers at all, and 5 is that I'm expert on containers. So that might give us a little bit of indication that what kind of people we have on the session today, and we could maybe customize the content a little bit and maybe focus the content based a little bit on the feedback. But I'm not sure if we have a chance to run such a poll over here.
I will see if it's possible to run such a poll.
Okay, but you can run that poll. So from 1 to 5, if you're not comfortable with containers, you don't have that much prior knowledge or experience, please enter 1. And if you are full certified expert on containers, you have worked with them for a long time, then you enter 5, and then the numbers in between are different shades of gray. But let's get started in the meanwhile, and if the poll is possible, Hilde will run it, but if not, then we just go as we take it. If someone is not familiar with Exclusive, we are a distributor specializing and focusing on delivering trusted digital infrastructure. And that means solutions in the cybersecurity space and also in cloud transformation. And we are a relatively large company. Last year, we had revenue of almost 3 billion euros, and we do have a presence in North American continent, in the EMEA, and also in the Asia Pacific markets. And the company has existed since 2003, and we have a quite high ratio from engineering to sales, which means that we try to really manage and know well the vendors we carry in the portfolio. And over the years, what we have seen is this journey through different type of innovations and trends and concepts that have disrupted the markets. And we have been trying to be part of this disruption, this innovation, and this container thing that has now really started to resonate bigly in the past couple of years. And what we are seeing is that both our customers, our partners, they are moving their applications more and more container based, but we are also seeing that many of the solutions we have in the portfolio, they are also built on top of containers. And now I can see that Hilde was able to set up the poll. So from scale of 1 to 5, please describe how much experience, how comfortable you feel with containers, and we will balance the rest of the session based a little bit on the feedback you give. And we give 1 minute to answer, and once the answers are done, Hilde can show us the results. And the technology partner of the choice for today, SentinelOne. If someone is not familiar with the vendor, they are one of the leading EDR vendors, performing extremely well in the past MITRE genuinity test lab comparisons, and they did perform well also last year. And we have been working together with SentinelOne, I think, since 2015. So we have a long history with the vendor, and like we saw this journey through or this history of an adoption of different technologies. We have seen this similar kind of development and progress taking place also in their product family. There's been a lot of emphasis and investment on AI, machine learning on their side. There's been they are definitely one of the innovators in the endpoint space, and we are definitely seeing that this container space is now resonating quite well among their customers. And Hilde, did we get, by the way, the results for the our survey?
Yes, we did. Most people answered 2 or 3 with how familiar they are with containers and cloud workload protection.
Okay, we really appreciate the feedback, because that really helps us to kind of consider how much time we are going to spend on the next coming slides. And based on that feedback, we are focusing on the first part of the session today. So we are going to give you, like, you know, a bit of backgrounding on the CWPP, and but also on the container space. And let's take it from there. And I just realized that this sharing for some reason is stopping. So let's. Okay, this is. Okay, let's make the main screen. Whenever I go into the full screen mode, and it pauses the sharing, but yeah, let's take it from there. So the security challenges we are seeing with the container space and within cloud, they are not that much differentiate from the traditional endpoints or servers. We have very similar challenges when it comes to, for example, too much noise. There's a lot of events, a lot of things happening in that space, and then the thing is that if you have a lot of like raw data, raw telemetry data, a lot of like something we describe and call noise, we are not able to correlate that information, or without having that information correlated, we might really not find the needle from the haystack. So there's too much noise taking place, like we are seeing with the traditional cybersecurity space. There's a lack of expertise, and I think this is emphasized in the cloud workspace. And one of the reasons being that there's quite many different cloud platforms. So then if you are an expert, or if your organization has experts on Azure, and then all of a sudden you need to work with the Google Cloud Platform, yes, many of the same things apply, and the analogy is similar between these two platforms. But at the same time, there's also a lot of like platform specific things that are different from between Azure, between Amazon, between Google Cloud. And then also, if we talk about hybrid cloud, which is also in our scope of today's session, then the hybrid cloud might be done on top of VMware, Nutanix, whatever is the chosen platform in your case. And then if we think about the way how these containers are used, so it's applications that we are running in those containers. It's software we are running in those containers. And because of the digitalization taking place across the industries and taking place at the most of the organizations now, especially during the COVID and after COVID, we are seeing a lot of like proprietary developed and customized software being developed for different businesses, for different business applications. And that means that there's software development teams doing development, and the culture and the way how these teams are working, they are they are often described for being quite agile. They want to develop things quickly, and they don't want to be stuck with the old legacy monolithic type of application development, where you have a long development cycles, long release cycles. But the idea here is to be a bit more agile and to have quick changes, and we are soon diving in bit more into microservices architecture and other things. the key point over here is that these teams might be beyond the software development teams. They might be beyond your kind of standard and regular security governance. They might be outside your traditional security controls. And that means that if your company is running applications that are not secure and they are not controlled by your existing tools, they might present a security like they might provide attack surface for anyone who is interested in getting into your network. And then this kind of traditional challenge, I think this is now getting kind of emphasized with these cloud workloads, that the more platforms we have, the higher is the risk that we might have blind spots. If we run something, for example, on public cloud, it might be that we are not having our firewall covering that part of the network, that part of the computing platform. It might be that we are not applying the our traditional. We have not been able to deploy for some reason our traditional vulnerability scanner to cover that part of the computing platform. It might be that we have not been able to deploy our traditional AD or EDR to that platform. And what is the outcome is that we are going to have possible blind spots where we don't have any defenses securing our workloads. But this is not unique for cloud workloads only. This applies also to a lot of like traditional environments and server platforms. But this just might, certain things over here like this a little bit different type of software release culture and few other things, they just might be emphasized here more than some other platforms. And then if we start going through a little bit the kind of, the basic terminology and the basic concepts over here. So we start from the kind of very basics. The VM, the virtual machine, that's a server we have running either in our local data center, in our private data center, or on public cloud. And any of the servers we have running over there are, we call them VMs. So for example, on AWS, the server or the VM the server machine you have running there, it's called EC2, and that's a VM. In Azure, it's also called as a VM, and the idea is that that's a server. And then what's the idea? On the next slide, we have a bit more like about the architecture, but we have containers, and it's like a software package that has all the libraries, binaries, and the runtime dependencies packaged into a single package, which is easy to move, it's very portable, and it has everything it needs to run, and it runs on top of the host OS. So then of course it needs the operating system in the below, but it's an isolated software package and contains everything it needs to run. And then something you hear often when we talk about containers is microservices. And this relates to the way how the applications are getting developed and how we want to structure and architect the applications and the software. So the idea over here is that instead of having one single monolithic application, we actually might have like a single service that is responsible for running the GUI we have another service that is responsible for running the database transactions. We have a third element of the application that is responsible for taking care of the network traffic of the application. And the idea of these microservices is that we can put put them running into dedicated containers or a collection of containers that are taking care of certain parts of the application. And the good part over here is that if we have some elements that require more development than some other parts of the application, we can focus on that particular part only, and we don't have to touch the other parts of the application. And the benefit with that type of approach is, of course, that if some parts are working well, we don't want to start touching and modifying them, but then we can modify only the small part of that application. And then you are going to hear a lot about two other terms. One is Docker and the other one is Kubernetes. So Docker is the kind of de facto technology that are used to manage the containers on the host. It's really the industry standard. And Kubernetes is then the orchestration tool that are used to manage when you have a high number of these containers running on Docker. So Kubernetes is the tool that is also like an industry standard, and it's used for management and orchestration of containers. And then we have one last term, which is the CI/CD pipeline, continuous integration, continuous deployment, which means or refers to modern software delivery process. And the idea here is that when we are writing the code and we do some modifications, we commit the code to a build server, it goes to unit testing, integration testing, and then it goes to a deployment pipeline, to staging, to production. The idea over here is that we are gonna be talking, and the Gartner CWPP this concept, it talks about different parts of this pipeline, and we are gonna get back to this pipeline and to different parts, how different tools are covering and how different techniques are covering securing the different parts of the pipeline. So generally we can say that what we are doing over here at this end are more like, before we go runtime. So they are techniques and tools we are using to do security and sanity check before we release the code, before we go live. And over here at this side, we talk about more like when the application is actually running, and we want to have secure the running application. And then if we think about the differences between the VMs, the virtual machines, and the containers, the biggest difference over here is that the idea with the VMs is that we virtualize one single computing platform, the hardware we have over here, the server. We are virtualizing that into multiple operating systems. And then it means that every single VM has its individual guest operating system. So whenever we spin up VM, it needs to have the operating system running below it, or the operating system is part of that VM. And here with the containers, the idea is that we have this host operating system, and then we are using this Docker engine that provides the resourcing for containers. And then what the container actually contains is the application only, and the binaries and the libraries it requires to run. And it practically means that it virtualizes the kernel the server is running. And what that helps us with is the fact that we don't need to put this guest operating system as a part of this container, which means that if we have a very high number of the containers and applications, these microservices, which are often packaged here into the container, it means that it's going to be so much more resource efficient to use this technology instead of this where you have this, let's say, 1 gigabyte of this operating system running on every VM. If you have 200 virtual machines, it means that you are having 200 operating systems running as on those virtual machines, and there's going to be a lot of resource inefficiency. The other good thing is that this makes it very portable, these containers. So if I need to send this container to another computing platform, I need to migrate it from our private data center to our public cloud, or maybe I just want to scale it there. We earlier ran it only on our local private data center, but we are gonna migrate it to, or we want to start using also the public cloud to scale it better. I don't need to worry too much about the dependencies of all the libraries. It's all packaged here in the container, and what I just need to make sure is that the server is running the same version of the operating system or the same kernel if we talk about Linux, and the container will work on that host. And scalability, that's definitely one of the biggest benefits you are getting here. It's auto scaling, so we can spin up these containers, we can start containers as we need resourcing, and they're starting, or you can start them in matter of seconds. They can be started very, very quickly, and that's very helpful when we have applications or services that have a short life cycle. And just to give you an example from real life, for example, when you are using Google Maps with your phone and you start the application Google Maps app, every time you establish a connection at the Google's end, there's a container there starts a container that is dedicated for handling the session data between your phone and the Google content servers. And whenever you have done with your Google Maps search and you have done with the session, the container dies. So if you think about how quick those sessions can be, they may range from a couple of tens of seconds of maybe to a few minutes, unless you are driving and navigating with that. So then everything that happens on that container, including security, everything must happen very, very quickly. And then if we go to this CWPP concept that Gartner is talking about, they released this market guide last year. And according to Gartner, CWPP protects server workloads from attack regardless of the location or granularity of the workload. We talk about this granularity of the workload on the next slide a bit more. And according to Gartner, most of the enterprises will have the workloads distributed across a combination of on-premises, co-location, and multiple public cloud infrastructure as a service platforms. This is called as the hybrid multi-cloud architecture, and CWPP must support this. granularity of the workloads, their lifespan, and how they are created are also changing. The majority of enterprises now have at least one Linux container-based application development, pilot, or production. And CWPP offering should start by scanning for known vulnerabilities in the development. At runtime, CWPP offering should protect the workload from attacks, typically using a combination of system integrity protection, application control, memory protection, behavior monitoring, host-based intrusion prevention, and optional anti-malware protection. And this is now what we are gonna dive into more detail, that how these things are actually done and how SentinelOne can help doing that. And here where we had this granularity of the workloads. So on this slide we have like the evolution of workload abstractions, and this is the world where we are coming from. The physical monolithic applications which were run on the dedicated hardware, and this is the direction where we are going to more and more like resources that are given available for the application just for the time that when they are needed. And on this path of evolution, we are somewhere here between the VMs and containers. So applications with microservice architecture, they can highly benefit and be more resource efficient if we use this container-based approach. And then if we have applications that needs resources only for very quick time or limited time, then we might even benefit from this kind of serverless computing. But the scope of our today's session is on these containers, and that's where most of the organizations are just moving to, or where they are involved right now. And as part of the market guide, Gartner described this kind of a CWPP pyramid. And the way how you read this pyramid is that there is like optional or things with less importance over here, and things that might be possible to perform even outside the workload. And then we have things that are described as the core workload protection strategies. And then we have a little bit this split between the actual runtime when the application is running, or the container is running, or the workload is running, and we have this development phase. And like we saw on the definition slide, Gartner says that yes, we want to harden and scan for possible known vulnerabilities here at the development phase. So that's the moment and the part where we are actually developing the code. And the idea is that, okay, once we have the code ready, we can scan the image, and if we detect any like possible, let's say, old vulnerable software development libraries as a part of or being used in the code, the idea of those scanners is to warn the software developers that, guys, we have a problem here. We have open ports running here, or there's old vulnerable library that should not be used because it makes your workload vulnerable for possible attacks and abuse. So please do and patch these. And then we have once we go live with the application and with the code, then we go to more like the normal way how EDR is working, that we are actually monitoring the host, the device, and the operating system and we start looking there that okay, is the system being kept, is the system integrity, is that assured, is someone trying to exploit the system somehow, what's happening on the network level, and excluding this scanning part, scanning the actual image. From the moment when we go live with the execution, running the application, the container, that's something that SentinelOne has always been doing, and that SentinelOne does extremely well. And if we go onwards, and by the way, the one last comment over here before we go onwards, that how the SentinelOne's own protection works. We can mention that when we go here to the higher we go here in the pyramid, the more security operations focused it is, so the more traditional security approach we can take, and the lower we go here, the more software development driven it becomes, and the key thing here is to make these two words meet each other, so that we are causing as little intervention for the development teams because they don't like it, but we are still making secure that this word of security and these controls from the security word are applied also on these cloud workloads. And for those of you who are not familiar with SentinelOne, the way how the vendor does the protection, it consists of several different stages and the engines that are protecting you. So we can start from the traditional hash-based protection, which is just comparing the hash of some particular file against the signature database. Might not be too relevant over here. And then the next step, if we even want to use it, but then we can do something that is called as a deep file analysis. And the idea is here that we train a model with machine learning by entering millions of files through like, you know, we have malicious files and the benign files, and we are extracting the features from those files that are categorized either being bad or good. And then we start learning that, okay, if it's a PDF file, if it's an executable, if it's a picture, whatever, how does look how does look a good file, how's the look of a bad file, and we extract something we call attributes of executions, and there are actually tens of thousands of those attributes that SentinelOne is extracting, and from those we can say that what's good, what's bad, and that's applied for the files. However, we do know that with the file-based analysis, we can cover we can cover things that are easy to detect from files. But then what we are seeing many times and increasingly is the fact that many times the code is, we just need a part of the code either on Linux or on Windows. It can be from PowerShell, it can be native tools of the operating system. And it's enough if we get that code executed somehow, and there's a lot of memory-based or memory-only based exploits and malware, which are never being able to be scanned by this type of file-based analysis. And then what happens is that we need to be able to monitor the behavior of the system. And SentinelOne is doing that with something they call dynamic behavior technology. And the idea is that it's listening the system on the kernel level, but also in the user space. And we start understanding what is happening on the process level, what's happening in the memory, what is happening on disk, what is happening on network. And we can start, or if something is deviating from normal behavior, if something is if we are seeing things happening that are not part of the normal behavior, the system will start paying attention and it will raise an alert. And if our policies allow, it will also stop that bad behavior or malicious behavior. If we start seeing indication that, okay, we believe that there's, for example, privilege escalation taking place, or there might be a signs of lateral movement or something else, but we are not sure, or the SentinelOne tool is not sure, it just might start giving you indicators that, okay, we believe that this might be bad behavior, but we are not sure, so let's flag this as suspicious. And this same approach applies to all 3 operating systems, and it can also be applied on containers if we are having Kubernetes, but you just need to have Kubernetes in use, and it will work also for containers. And then if bad things happen, we have, of course, we want to have the remediation and mitigation tools and the response tools available. So we can kill and quarantine, we can kill the offensive processes, and we can quarantine the possibly malicious files. We can do easily cleanup for the malicious behavior. We can even roll back to the latest known good configuration, and that applies mainly on Windows. We can disconnect the container, the workload, the server from the network, so that we can do run our forensics and our response and remediation for the device, and so that the malware can spread any further if that's the case. We can even control the file or run the firewall controls, and we are doing a lot of integrity protection, integrity checks on the workloads. And then if need be, we can run searches across our entire server base, the server install base, or the workload install base, that have we seen this similar behavior taking place anywhere else in our environment. And the way how it looks is, of course, that we have hundreds or thousands of the processes running on the device, and it's very difficult to detect if something here is good or bad. And then we know that it's enough that on one story, as we call it, and this consists of multiple different processes, so it's enough that one of the stories has one single point in time where something bad happens, something malicious happens, and then that can lead to chain of a number of actions that might be harmful for our organization. And it's important we try to prevent this thing happening, but as we know, there is no such thing as 100% protection. So then it's very, very important we can detect that something bad has possibly happened, and we are able to detect that there's bad things taking place. We don't want to rely only on the approach that we try to always prevent these things happening. That's ideal, but it's not very realistic. We need the detection and also response capabilities after possible infection takes place. And if that happens, we definitely want to be able to roll back and respond to that infection. And then the way how this would, the same thing would look like on for example, on Windows is over here. So we have, executable running here, which then has a lot of like child processes, and then these are spanning more processes here, and then there's something that is not part of the valid behavior, and that is causing a lot of deviation from what we have categorized and detected as a good behavior, and we want to stop this. So Now you understand the logic and the way how SentinelOne works, and we have discussed a little bit about the kind of the basic concepts of this Gartner's cloud workload protection platform approach and the things it is supposed to do. So let's discuss briefly how we are actually doing this on Kubernetes. So this can be done on the private clouds, but also on the three major public cloud platforms. And all of these cloud platforms, they are running their own version of Kubernetes. So all those three Kubernetes engines are supported. And what you get with SentinelOne is a pretty comprehensive coverage of different operating systems. You get the protection, or it's compatible with the 10 major Linux distributions and for 12 years of Windows servers. And this number of Linux distributions is been quickly growing and evolving, and SentinelOne has generally added more distributions as the customers has requested it. So if for some reason your preferred distribution is not there, it might be there with the next release. The same approach and the way how this works applies to both the traditional VMs, but also to Kubernetes and Docker. We get this runtime protection and also remediation. We can have an application control for the containers, which means that we can define every single application we want to allow to run on that or in that container. That helps us to limit the code execution possibilities only to applications we really want to run there. You get the exactly same EDR capabilities as you would get with your traditional endpoint. And in the case something bad or unexpected happens, you have the full remote shell capabilities, you have the full forensics and the full response capabilities SentinelOne offers for any other environments. And it's very, very scalable, as it needs to be with the containers. And no matter on how many platforms you are running the agent, it all will be managed from the same single console. And if you are a service provider serving and helping many separate customers, there's a strong multi-tenancy built into the operating system. Also not the the management console, which means that you can, for example, create customer specific tenants and customer specific policies, but you can also roll out global policies that apply to all tenants. And then we are expecting very soon to see something that is called as SIS benchmarks, and that means that if you deploy SentinelOne to these cloud platforms, to the workloads running on these cloud platforms, it can also check the underlying host and its configuration. So for example, do you have like default password running or set on the device? Is there a strong authentication? SIS benchmarks, it's like the industry standard for reviewing those your cloud configurations. And SentinelOne is planning to release a feature that helps you to review the configurations and harden the configurations. And that is a very helpful feature when it comes, because configuration errors or the bad configurations are right now the biggest source of problems what comes to these public cloud platforms. And then we are gonna start seeing something called file integrity monitoring reports, but that's also a feature for coming releases. And then for people who are working with the actual deployments, the way how this is deployed, works that there's an image and then the container that's a runtime instance of that particular image, and the images are stored with the containers, something we call as the registry, and then we have different versions maybe of the same image, so we can differentiate those images, something called tags. And then the registry is it's in the repositories, and then this repo holds all the versions of the specific image. And in the case of SentinelOne, by default, it's the GitHub where we are where the images are stored. So those are like the install packages for this. And this is the path to accessing it, and here is the version, and then you need the token for accessing that particular image. And the way how it's deployed is done. It's done with Helm, which is a standard package management tool for Kubernetes. So if you are familiar with apt-get or RPM or something similar, this is the same thing but for Kubernetes. And it's deployed as a daemon set. It's using a daemon set. It's like a daemon running on a privileged container, and it can see exactly what is happening on the kernel level on that particular container. And it's deployed on the node level, so it's the underlying node hosting this Docker container engine. And the good thing with this daemon set is that, and the approach SentinelOne has, is that it's not like a sidecar. So if some of the vendors are using a mechanism called a sidecar, it's like an additional container or a pod. So the pod is Kubernetes abstraction for containers. So the containers are running in something that are called pods. So then with the sidecar, the idea is that there would be an additional pod. And the thing is that for every single namespace over here on each of the nodes we are running, we would need to spin for every single namespace. There would be one additional pod with the sidecars. But the way how SentinelOne does is that for every node, so this is one node, one VM, one server, and that's managed. This is a Kubernetes cluster over here. So you have one master node where you are controlling this whole thing, and then you have these worker nodes, and there can be many more of these. So then the idea is that you divide these resources into namespaces, and these are isolated resource pools over here, but still, sharing the same host node. So the idea here is that SentinelOne will be running here in this privileged pod, and it can have visibility across these different or in through the whole node over here. And it's not protecting only these pods and containers we have here, but it's also protecting these underlying node, the server. And that's a very useful approach, because then you get the visibility to the whole thing. And the good thing with this daemon set is that it auto scales. So whenever we are setting up whenever there's new pods starting or new containers starting, or so it means that we are having full visibility across all of them. And the good thing is that when it's no matter if the life cycle is 10 seconds or if it's 5 days or 1 year, this will live automatically with that. And speed of deployment is very fast, and also if your pods and containers they die, they are not needed anymore. These will be, the agents also will be removed as it goes, and that means that you don't really need to worry about this when we are working with this. And it also quite resource efficient because we needed one per node. And the way how you license this, because it's impossible to keep count of all these individual pods over here, the containers, but the way how you license this is based currently on this number of these nodes. So how many servers you have hosting these containers. And that makes it also pretty predictable that how it works. And if you need to speak with the people who are working with the software development, with this code development, the way how this is deployed, it's exactly, it's working in the very similar way how they would work with their other things on these on Kubernetes and on containers. And that means that if we think about deploying this, it's something, we talk about terminology, we talk about the ways of working that are familiar for them, and they probably will feel comfortable, and it's causing also very little disturbance and disruption for those guys. So it's not like something big you need to deploy over there, and that's something they want to avoid. I think we are running into the end of the session what comes to time, so maybe not jumping into a demo now, but maybe wrapping up a little bit like what we have discussed so far today. So this race to deploy, and we have the kind of defenses it has, they are now proven in many different tests. And the customer loyalty of SentinelOne customers, it's pretty high. So I think that's a strong indication that the customers like what they receive. You can run this on pretty much on top of any operating system, so that's good. And the product is developing with very high pace, so you are not going to be disappointed that if something is not there, it's probably there already in the next release. And this scales very well for all the use cases you have. And you are going to get the full runtime protection for the dynamic containerized workloads. And the deployment is very simple and it auto scales. It's not only strong performance in the MITRE tests for 2020, when SentinelOne was one of the few companies talking about it, but now you have seen this year that everyone has been great and performing well in there, and everyone have been best at this test. But if you look at by some of the bit more neutral comments, not from the vendor, the reality is that SentinelOne performed really well also this year. It provides you all these MITRE TTPs and the indications, and generally the thing is that it keeps you secure. If someone wants to discuss this more detailed, maybe see a demo, which we did not have time to run today, I suggest you reach out to Lars or whoever is your local point of contact at Exclusive or SentinelOne, and we are happy to set up a session for you and to review this bit more detail.
Yeah, sure. That will work. If you want to follow up on this, just contact me. I'll take it from there. Thank you, Tapio.
Thank you, and for all the attendees. And as said, we are happy to run the demo to show you a bit more detail, but it's gonna take at least 15 minutes. So I don't want to do it like 2 minutes now, and then you are just gonna see the very beginning of the whole thing, and then we get stuck.
Not
we have
any question in the question box. I'm not sure if someone does have a question right now. Perhaps we can take some minutes to answer those if there are any questions left. Otherwise, you can also ask them to me after the session, and I will make sure that we answer them properly. And if we need to, we will reach out to you, Tapio.
Yep. So if someone has any questions, we are happy to answer right now. But if not, here is just like just want to show the screen over here how it would look for you. So you are seeing a lot of information about on things where the container is running. You see the application path, the command line arguments, if any are used. You are getting all this information over here about the namespaces, the pods, the containers. And then for those who are possibly a bit more familiar with SentinelOne, you have all these same features available for containers as you would have for the traditional endpoints or your servers. And there are some quite big references that cannot be publicly disclosed over here, but there's some very large organizations using this for their container protection.
Yeah, that's also what it makes really strong, in my opinion, that if you're already used to the philosophy of SentinelOne and the way they approach the endpoints and the servers and the way they analyze incoming threats, that now for the Kubernetes environment and the Kubernetes worker node, that you kind of have the same look and feel to it. So I think it's a really strong addition, and you see on everything that SentinelOne really is focusing on this cloud workload environment. If you take a look at their roadmaps and follow their channel updates, it's a topic that keeps coming back.
Yeah, and SentinelOne has, so everything you said, I totally agree. And SentinelOne has been working on the Linux protection also for many years already. So this is not something that they just came up with 3 months ago and say that okay, now we are cloud compatible. But it's something they've been working for a long time. And the ideology how these containers work, there's just a bit different way of allocating the resources and orchestrating and managing them, but then the kind of the ways how you actually protect the operating system and you monitor it, that doesn't really differentiate that much from what they have done before. So it's a very natural evolution for SentinelOne. And as you can see, this is the management console. So now it is just saying that, this is Kubernetes container, what we are having over here. But if it was a Windows, it would show me that, okay, it's a Windows endpoint. So it's exactly, so if you are familiar with this is very easy to adopt.
Exactly, I agree. So still no questions in the question area. So I think your story was quite clear. If something pops up afterwards, just contact me and I will make sure we take it from there and cover any uncertainties or interests in demos, etc. afterwards. So thank you again, Tapio, and thanks everyone for attending today.
Thank you for all the attendees and wishing you a great day.
Bye-bye.
Bye.